All right, this is going to be a crash course in everything you need to know about continuity and differentiability for the AP exam. Let's begin with continuity, and I'm just going to sketch some quick graphs here. There are 4 types of discontinuity. One of them is what's called the removable, or it's just a hole in the graph. The next is the infinite. This is where we have an asymptote. Like that. The next is what's called the jump, where we've got a function going along, and all of a sudden we jump up here. And the last is called the oscillating. Something like that. Those are the 4 types of discontinuity. Again, we have the removable, the infinite, the jump, and the oscillating. Now, what makes the removable special is that it is the only one that has a limit that exists. You see, it approaches the same value from both sides. I'm going to very quickly just add a little bit of detail to this graph, and I'll explain why in a second. Let's say we were at 3, and we were 1, 2, 3, like that. We can fix this discontinuity by saying, well, the function is the graph. I'm just going to say the graph. I know that's bad. As long as x isn't 3, we have a hole at 3. But at 3, I want to fill that hole like that. We call this a continuous extension. Okay? For that. So we can fix the discontinuity, and that's why it's called removable. Again, you can't fix any of the others because the limit doesn't exist. Now, to be differentiable, there are pictures that people normally think about. So let me again draw. These are things that make a function not differentiable. A corner, a cusp, a vertical tangent, or any of the discontinuities. Now, what this really means, what differentiability really means, is that the function and the derivative of the function are continuous. And the easiest way to think about this is with the absolute value graph. If I can just add in a quick axes here. On this side, the derivative is -1, and on this side it's 1. So if you were going to graph the derivative, it would look like this. And therefore, there's a discontinuity in the derivative, and that's why we say it's not differentiable. So differentiability, again, really just means both the function and its derivative are continuous. So you can see here, of course, why here the slope is getting really, really, really positive, and then all of a sudden it's really negative. There's an infinite discontinuity. With a vertical tangent, the slope is undefined here. Okay? One other thing you should be prepared to do on the AP exam with continuity. If you are given a piecewise, and let's say it's x squared plus 2x plus 7, if x is less than or equal to 1, and it's 3x plus a if x is greater than 1, and find a to make the function continuous. And the way to make this continuous is to figure out, well, what is each side approaching? So I would plug in 1. I would say, okay, 1 squared plus 2 times 1 is 3 plus 7 is 10. So this at 1, the function is approaching 10. Well, here at 1, if I plug 1 into the bottom piece, 3 times 1 plus a, this is approaching 3 plus 3 plus a. Well, they need to be the same. To be continuous, the two pieces need to be equal. So solving this, a needs to be 7 to make the function continuous.